Hi Nicole, this is your Uncle Albert. I tried to make this little movie for you to answer some of your questions. You're asking questions about people, energy, and the planet. These are complicated questions for someone in second grade, but I'll try to answer them as best I can. And if you don't understand them this time, in a year you can watch the video again and maybe you'll understand better. Here we go. When we talk about energy, we really need to remember as people on this tiny little planet of ours that all the energy we have, no matter where we get it from on the planet, comes from stars. It comes from stars from the very beginning of the universe. These beautiful stars give us all we need to live. Our star, our sun, rises every day in the east and sets in the west as the earth turns. The sun provides us with all the energy that we need to live. All the animals on the planet, the plants, all they use basically is the energy given by the sun. People, on the other hand, want more energy. They want more energy to do things faster, build things bigger. So that's where the use of energy and wondering about it comes in. Our star, the Earth that we live on, is very small compared to the size of our star, the sun. This picture shows a little blue ball that's the size of the Earth next to a larger ball that actually is a picture of the sun. You can see the Earth is much, much smaller. Our star, the sun, is not the biggest star. In fact, it's kind of small. There are many bigger stars that don't live as long. These big stars often end their lives in big explosions. And the big explosions give us things like carbon, oxygen, and nitrogen that we need to live. They make up our body. And also things like silicon and copper and iron for rocks and for tools. Without the bigger stars, some of which are shown here after they've blown up, we wouldn't have all of the elements we need for life to make the planets, the animals, people, birds, and none of us would ever have come to be. So not only do we get energy from stars, but the things that make us up are from stars. We are made of the stuff of stars. When some of the biggest stars explode into supernovas, they give us elements like uranium, very heavy elements. And these stars give us very ancient energy stored from billions of years ago in the form of these very heavy elements. And there's a lot of energy in them. So even uranium comes from stars, like all the other kinds of energy that we use. The oil, gas, and coal that we use to make energy now, like for example to heat our houses or run our cars or to cook our food, comes from trees that lived 300 million years ago. And 300 million years ago there were a lot of trees and plants, even more than there are now. These trees and plants got their energy from our sun. And when they died and went into the ground, and over a long time they became oil, gas, and coal. And now we mine them or drill for them to get them out of the ground. To get the energy from these old trees, we have to burn them. And when we burn them, the smoke and waste from getting that energy goes into the atmosphere as smoke. And we call that pollution. People try to find cleaner ways to get energy. People try wind from wind farms and big windmills, and solar energy from silicon, from sand that's just everywhere in the rocks. Of course, these don't also come without a cost of pollution, because we have to mine the materials that go into them, and the big windmills sometimes hit birds and that can cause a problem because the birds get killed. So nothing is sort of for free. There are consequences to all the different kinds of energy we might want to use, including wind and solar. So this is a picture of the core of a nuclear reactor that you asked me about, and you wanted to know why it was blue. Well, the reason it's blue is very complicated, but I'll explain it to you. And you can listen again, and maybe in a year or two you'll understand more. The radiation, the blue color, is called Cherenkov radiation. It was named after a physicist named Cherenkov. And the reason it makes the blue light is because some of the radioactive material, some of the nuclei in the core of the reactor release electrons that travel very, very close to the speed of light. But it turns out that in water, the speed of light is a little bit slower than the speed of light like in the vacuum of space or in air. And because these cores are in water, they release this Cherenkov radiation, which is a very pretty blue color. Of course, nuclear reactors also have waste, just like coal, gas, and wind and solar power. Nuclear reactor waste is very, very concentrated. It's very deadly and dangerous. But there's much less of it than there is if you burn coal or gas. So to take care of it, we want to put it in big caverns that we dig out under mountains. And this is a picture here of a place called Yucca Mountain out west, where people have dug big holes to store radioactive waste from nuclear reactors. So I tried to give you an overview of where we get all of our energy and what the choices are that we have, and what people talk about when they talk about energy and what they mean. So what's best is difficult to decide, and whether nuclear power is good for the environment is also difficult to decide. Probably burning oil and coal is bad. It's probably one of the worst things we can do, and eventually we have to stop doing that. Solar power is probably better than burning oil and coal, but it's not great either, because we have to mine the materials for it, and also there are chemicals involved that are not very nice, and we have to dispose of that waste too. Wind power is probably the next best thing, but there are problems with that too. Nuclear power could be pretty good if we can be careful with the waste and with safety. But people being people, that's hard to do. People make mistakes. Probably the best thing in the end is using no extra energy, like the animals and plants. Only energy from the sun is the cleanest energy, and that's what's best for the planet. So using less energy or almost no energy at all is always the best solution. I hope this helps. Love you, Nicole. Bye-bye.